Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2007, so let's get started. First problem. Isabella's house has 3 bedrooms, each is 12 feet long, 10 feet wide, and 8 feet high. Isabella must paint the walls of all the bedrooms, doorways, and windows, which will not be painted, occupy 60 square feet in each bedroom. How many square feet of walls must be painted? Okay, so we want to do 3 times 1 bedroom, so it's 3 times, and the 1 bedroom is 8 times 10 plus 12 plus 10 plus 12, because that's all the walls. But then 60 square feet in each bedroom are doorways and windows, which will not be painted, so that's minus 60, right? So this is 3 times 8 times 44, 8 times 44 minus 60. This equals 350. Yeah, this equals 3 times 292, which is equal to 876. So this is the answer, which is E. Number 2, a college student drove his compact car 120 miles home for the weekend and averaged 30 miles per gallon. On the return trip, the student drove his parents' SUV and averaged only 20 miles per gallon. What was the average gas mileage in miles per gallon for the round trip? Okay, so the total amount of gas used, this is going to be equal to 120 over 30 plus 120 over 20, right? So this is going to be equal to 4 plus 6, which is 10 gallons. 10 gallons. And then this was for a total of 240 miles traveled. Right, so it's 24 miles per gallon average, right? So it's 24, it's B. Number 3, the point O is the center of the circle circumscribed about triangle ABC with BOC equals 120 and AOB as 140 as shown. Where's the degree measure of ABC? And ABC is this one, and we know that ABC, this is half of AOC, right? And we know that AOC, this is 360 minus 140 minus 120, which is 100 degrees, so this must be 50 degrees, so the answer is D. Number 4, at Frank's Fruit Market, 3 bananas cost as much as 2 apples and 6 apples cost as much as 4 oranges. How many oranges cost as much as 18 bananas? Okay, so 3b, 3 bananas equals 2 apples, and 6 apples equals 4 oranges, right? And so this is going to be equal to 9 bananas is 6 apples, right? Which equals 4 oranges. So we can see that 9 bananas equals 4 oranges. And so we want 18 bananas. So 18 bananas equals 8 oranges. Right, so it's 8 oranges. The answer is 8. It's B. Number 5, the 2007 AMC 12 contests will be scored by awarding 6 points for each correct response, 0 points for each incorrect response, and 1.5 points for each problem left unanswered. After looking over the 25 problems, Sarah has decided to attempt the first 22 and leave the last 3 unanswered. How many of the first 22 problems must she solve correctly in order to score at least 100 points? Okay, so since she has left 3 unanswered, that means she will get 4.5 points at least, 4.5 points, right? And then she wants 100 points at least, so she needs 95.5 more, right? And then 6 points is each correct, so if we say that she got x correct, then 6x must be greater than or equal to 95.5, and the least value of x that does that is 95.5 over 6. This is 15 point something something, so x is going to be equal to 16. It's so the answer is 16. It's D. Number 6, triangle ABC has side length AB equals 5, BC equals 6, and AC equals 7. 2 bugs start simultaneously from A and crawl along the sides of the triangle in opposite directions at the same speed. They meet at point D. What is BD? Okay, so if we draw any triangle like this, let's say this is A, B, and C, and AB is 5, BC is 6, and AC is 7, right? And then they start from A, and then one goes like that, and one goes like that, right? And they will meet at point D. And what is BD, right? So we want this length. If we say that length is x, then this length would be, since 5 plus x must equal 7 plus this much, that means this is x minus 2. And since the whole thing is 6, that means 2x minus 2 equals 6. So that will mean x equals 8 over 2, which is 4. Right, so x is 4. The answer is 4, which is D. Number 7, all sides of the convex pentagon ABCDE are of equal length, and angle A equals angle B equals 90 degrees. What is the degree measure of angle E? Okay, so that means that we just have a square plus an equilateral triangle, right? So this will be A, B, C, D, and E, right? And so these 2 are 90, and we want the degree measure of E. So this is 90 degrees plus 60 degrees, so 90 plus 60 equals 150. So it's 150 degrees, it's E. Number 8, Tom's age is 2 years, which is also the sum of the ages of his 3 children. His age n years ago was twice the sum of their ages then. What is t over n? Okay, so t right now is equal to the 3 children. Let's say it's a plus b plus c, right? A, b, and c. And then n years ago, so that was t minus n. T minus n equals twice the sum of their ages then, which is a plus b plus c minus 3n, right? Because there were 3 kids. And so this is equal to, since a plus b plus c equals t, and if we substitute that, that's 2 times t minus 3n, which is equal to 2t minus 6n. So t minus n equals that. So this one can give us that t equals 5n. So t over n, this is going to equal 5n over n, which is equal to 5. So this is the answer, it's D. Number 9, a function f has the property that f of 3x minus 1 equals x squared plus x plus 1 for all real numbers x. What is f5? Okay, so for this to be 5, that means x is equal to 2. And so if we just plug in x is equal to 2 right there, then this will give us 2 squared, so which is 4, plus 2, plus 1. This is 7, right? So it's 7, it's A. Number 10, some boys and girls were having a car wash to raise money for a class trip to China. Initially, 40% of the group are girls. Shortly thereafter, 2 girls leave and 2 boys arrive, and then 30% of the group are girls. How many girls were initially in the group? Since 2 girls left and 2 boys came, that means the total amount people are the same. Total is the same, right? And then we have 2 girls leave, right? So that means the 2 girls who left is equal to the percentage that decreased, which is 10%, which is 40 minus 30. So that's 10% of the group. And so that means that we want the amount of girls that were in the group at first. So 40% of the group. So that's 40% of the group who are girls. So that means 40% of the group. This is 2 times 4, which is 8 girls, right? 8 girls. That means there were 8 girls at the start. So the answer is 8. It's C. Number 11, the angles of quadrilateral ABCD satisfy A equals 2B equals 3C equals 4D. What is the degree measure of A rounded to the nearest whole number? Okay, so if we just look at the ratio of the angles, A to B to C to D, that's going to be equal to 1 to 1 over 2 to 1 over 3 to 1 over 4, right? And so that equals 12 to 6 to 4 to 3. If we just look at these numbers, then these have a total of 25, right? But then since they are the angles of a quadrilateral, that means they have to be total of 360, right? And so to get the actual angle, then we have to multiply 360 over 25. And we want the degree measure of A, right? So this is A, so that means A is 12 times this much, 360 over 25. And so this is going to be equal to 12 times 72 over 5, which is 172.8. So this is the nearest to 173. This is nearest to 173, right? So 173 is our answer. It's D. Number 12, a teacher gave a test to a class in which 10% of the students are juniors and 90% are seniors. Okay, so let's just say it's 1 junior, and 9 seniors, right? And that so the average score was 84. So the total of the score was 840. And the juniors all received the same score. That makes sense if we just say it was just 1 junior who took the test. And the average score of the seniors was 83. So since there were 9 seniors, the senior total, this was going to be equal to 9 times 83. 9 times 83. And then what score did the junior receive on the test, right? So that's just 840, which is this much, minus the senior's total, 9 times 83, right? Easy way to do this is just to say this is equal to 840 minus 9 times 84 plus 9, right? So this is just the same thing, and so we can just do this first. That's 84. This is 84, and then we just add that much, tack that on, which equals 93. So it's 93, which is C. Number 13, a traffic light runs repeatedly through the following cycle: green for 30 seconds, then yellow for 3 seconds, and then red for 30 seconds. Leia picks a random 3-second time interval to watch the light. Where's the probability that the color changes while she is watching? Okay, so total we have 30 plus 3 plus 30, so that's 63 seconds. The color change, that can be from green to yellow, yellow to red, or red to green. So we have 3 of these, and And since each of those times are at least 3 seconds, and she picks the random 3-second time interval, that means each has 3 seconds, right? And so these together, this is 9 seconds. So that means Leia has 9 seconds to watch the traffic light change in a total of 63 seconds. So that's 9 over 63, which is equal to 1 over 7. So this is the answer. It's D. Number 14, point P is inside equilateral triangle ABC. Points Q, R, and S are the feet of the perpendiculars from P to AB, BC, and CA respectively. Given that PQ equals 1, PR equals 2, and PS equals 3, what is AB? Okay, so if we bring out an equilateral triangle like that, let's say, yeah, this is A, B, and C, right? And if point P is somewhere here like that, right? Then yeah, we know that PQ are Q, R, and S, they are the perpendiculars from P to AB, BC, and CA. So they will be, I'll do this in green, they will be these lines like that, and like that, and like that, right? So these are all right triangles, right? And their lengths are 1, 2, and 3, right? So their lengths will be 1, 2, and 3, and we want the side length. So what is AB? And let's say that AB, this is X, right? And we know that since these are all X, then we know that the area of the whole thing, this is going to be root 3 over 4x squared, right? But then that area can also be divided into 3 of these triangles, right? And since we know the base and height of each of these triangles, like that, and like that, right? Then we can get this area plus this area plus this area to get the whole triangle, right? So this is going to be equal to this much, which is 1 times x over 2 plus this much, which is 2 times x over 2 plus this much, which is 3 times x over 2. So this is going to be equal to x over 2 times 1 plus 2 plus 3, which is 6. This is 3x, right? And so this and this are equal. Yeah, so that means root 3 over 4x equals 3. X equals 12 over root 3, which is 4 root 3, right? So this is 4 root 3, it's D. Number 15, the geometric series a plus AR squared all the way has a sum of 7, and the terms involving odd powers of r have a sum of 3. What is a plus r? Okay, so if we just look at this clause, then that will give us that since it's a geometric series, a over 1 minus r is equal to 7, right? And the terms involving odd powers of r, these one, they're ar cubed, ar to the 5th power, so on. So this is going to be ar over 1 minus r cubed, sorry, r squared, right? And this is going to be a times r over 1 minus r, 1 plus r. And since we know this value, that's this one, which is 7, so that we can just say that this is 7 times r over 1 plus r, right? So that's 7r over 1 plus r, and this is equal to 3. This is 3, right? So 7r equals 3 plus 3r, so 4r equals 3, r equals 3 over 4, right? So r equals 3 over 4, and by this one we can get a. So a equals 7 times 1 minus r, which is 7 times 1 minus 3 over 4. This is equal to 7 times 1 over 4, so 7 over 4, right? So a equals 7 over 4. A plus r is 7 over 4 plus 3 over 4 equals 10 over 4, which is 5 over 2, right? So it's 5 over 2, that's E. Number 16, each face of a regular tetrahedron is painted either red, white, or blue. Two colorings are considered indistinguishable if two congruent tetrahedra with those colorings can be rotated so that their appearances are identical. How many distinguishable colorings are possible? Okay, so if we bring out a tetrahedron shaped like this, like that, right? And it's either red, white, or blue. Okay, so we can have so we can differentiate this by the number of colors that the whole tetrahedron is going to have, right? Number of colors, right? So if the whole tetrahedron is just gonna be one color, then that's gonna be 3 choices, right? If it's either all red or all white or all blue, and if there are 2 colors, we could have 2 triangles, like those 2 be one color and the other triangles be a different color, right? So that's going to be 3 choose 2, right? Which is just choose the first 2 which color they will be, and then choose the next 2 which color they will be. So that's just 3 choose 2. Plus, we could also have just one face be a different color, and all the others, so the other three will be the same color, right? And so that will just be choosing 3 colors for the bottom one, times choosing one of the other 2 colors for the sides. So that's times 2. And so this is going to be equal to 3 plus 6, which is 9, right? And then if we have 3 different colors, that means since we have 4 sides on the tetrahedron, that means we are going to need 2 faces that have the same color, right? So first we will choose 3, right? So choose the color for the 2-faced one. So let's say that's this face, and that was 2, right? But then for the faces that are left over, they will just be the same thing because if they are flipped, they're just going to be the same. So that's all. Right, and so what we have to do now is we have to add these up. 3 plus 9 plus 3 equals 15. So it's 15. That's the answer. It's A. Number 17. If A is a non-zero integer and B is a positive number such that AB squared equals log 10 of B, what is the median of the set 0, 1, AB, and 1 over B? Okay, so since this gives us that B equals 10 to the AB squared power, and so let's say that B is equal to 1 over 10, right? Then AB squared would be equal to -1, right? And so A would be equal to -1 times 1 over B squared, which is -100. So these would be, so that would be 0, 1, and then A, which is -100, and B, which is 1 over 10, and then 1 over B, which is just 10. So for the median, we just find the third largest number, which is, this is the smallest, and then this is the next smallest, and this is the third. So it's 1 over 10, which is equal to B. So it's B, it's D. Number 18, let ABC be digits with A is not 0. The 3-digit integer ABC lies 1/3 of the way from the square of a positive integer to the square of the next larger integer. The integer ACB lies 2/3 of the way between the same 2 squares. What is A plus B plus C? Okay, so we have x squared and we have x plus 1 squared, right? And we'll just rewrite that as x squared plus 2x plus 1, right? And so we will have ABC here, and we'll have ACB like that, right? And that's 1/3 of the way between those things. This length, that's just 2x plus 1, right? That means ABC, so ABC, which is 100A plus 10B plus C, this is going to be equal to x squared. That's going to be equal to x squared plus 1/3 of 2x plus 1, so 2x plus 1 over 3, and this much, which is ACB, so 100A plus 10C plus B is going to be equal to x plus, it's going to be equal to x squared plus, and then 2 times that over 2, so it's 4x plus 2 over 3. If we subtract this one from that one, then we are going to get 9c minus 9b equals equals 2x plus 1 over 3, right? That means that 2x plus 1 over 3 is a multiple of 9, right? So that means multiple of 9, so that means 2x plus 1 is a multiple of 3 times 9, which is 27, right? And so if we say that this just is 27, that gives us x equals 13, right? And so if we test to see that, then that gives us numbers of 13 squared, so 169, and then 196, right? And so this much, the distance is 27, so the distance is 27 distance, so that means 1/3 of the way after that, that will be 178, right? And then 9 more, that will be 187, and this is just ABC and ACB, right? And so that means ABC is 178, so these 1 plus 7 plus 8 equals 16, so 16 is the answer. It's C. Number 19, rhombus ABCD with side length 6 is rolled to form a cylinder of volume 6 by taping AB to DC. What is sine of ABC? Okay, so if we bring out the rhombus, then let's say it's A, B, C, D like that, right? And its side length is 6, so that means it's 6 on these sides, and it's rolled to form a cylinder of volume 6. So if we roll this, then that will become a cylinder, so like this, and this will have volume 6. But then since this length equals the circumference, that means the circumference, circumference of this equals 6, right? So that means 2 pi r equals 6, r equals 3 over pi, right? So r equals 3 over pi, and the volume is 6. That means if we set the height as h, that means pi r squared h equals 6, and so it's pi times 9 over pi squared times h. 9 over pi squared times h equals 6, right? And so these pi's can get cancelled, so h is going to be equal to 6 times pi over 9. So this is 2 pi over 3. Yeah, so h equals 2 pi over 3. So that means that this length, that's h, this equals 2 pi over 3, right? And so sine ABC, so sine of that length, and since this is 90 degrees, then sine of ABC, that means it's AB over, no, sorry, that means it's this length over that length, and we know that AB is 6, right? Because it's because it's side length 6. And so sine of ABC equals to 2 pi over 3 over 6. So this is 2 pi over 18, which is pi over 9, right? So this is our answer, pi over 9, it's A. Problem number 20. The parallelogram bounded by the lines y equals ax plus c, y equals ax plus d, y equals bx plus c, and y equals bx plus d has area 18. The parallelogram bounded by the lines y equals ax plus c, y equals ax minus d, y equals bx plus c, and y equals bx minus d has area 72. Given that a, b, c, and d are positive integers, what is the smallest possible value of a plus b plus c plus d? Okay, so if we draw a diagram here, then it's going to look something like that, right? And we see that the two parallelograms that we are talking of, it's this one and this one, right? Since we know these lengths, right, that's d minus c and d plus c, so this is d minus c and this is d plus c, right? And their areas are 18 and 72. So the upper one is 18 and the lower one has 72 area, right? What we want to do now is we want to get these points, right? Because if we get those points x values, then then we see that this length times this length, that's just the area of the whole parallelogram, and same thing on the bottom here. If we have this length times this length, right, with this as perpendicular, that means that this times this, so that will give us the area of the whole thing. And so now let's try to get the intersection between ax plus d and bx plus c. Yeah, so that is just going to give us x is equal to x plus d equals bx plus c. So a minus bx equals c minus d, right? So x is equal to c minus d over a minus b, which will just change to d minus c over b minus a, right? And then for this one, that's going to be ax plus c. So because that's this line, this is ax plus c and bx minus d, right? So it's ax plus c equals bx minus d. So that will give us a minus bx equals minus d minus c. So x equals minus d minus c over a minus b, and we'll just change that to d plus c over b minus a, right? So we have x of d minus c over b minus a and d plus c over b minus a. So we can just multiply that times these times the vertical lengths. And so first for the upper triangle, right, that's going to be 18 equals d minus c times this, which is d minus c over b minus a, which is d minus c squared over b minus a. For this, we will get this length and this length, right? So this is going to be 72. This is going to be equal to d plus c times d plus c over b minus a, which is going to be equal to d plus c squared over b minus a. And comparing these two, right, they are 72 to 18. So those ratios, that's going to be 72 to 18, that's 4 to 1, right? So 4 to 1 equals this much to this much. And since the denominators are the same, we can just look at the numerators, right? So that's d plus c squared to d minus c squared. So this is going to be equal to, so this gives us 2 to 1 equals d plus c to d minus c. That means d to c is 3 to 1. That gives us d to c equals 3 to 1 also, right? And so since d minus c squared, that will be 2c squared. That's 2c squared, which is 4c 4c squared over b minus a, right? But then since this is 18, that means that b minus a is multiple of 2, right? That just means that it's even. B minus a is even. It must be a multiple of 18, so c squared must be a multiple of 9, right? And since we want the smallest possible values of a, b, c, and d, then for this we'll just say that c is equal to 3, b minus a would be equal to 2, and if this is true, then the smallest possible value of a and b, those would be a equals 1 and b equals 3. And then since d to c is 3 to 1, that if c is 3, this will give us d equals 9, right? So we have a, b, c, d values. They are 1, 3, 3, and 9. If we get those together, yeah, so 1, 3, 3, and 9, these are going to equal 16, right? So that's the sum. The answer is 16, which is D. Number 21, the first 2007 positive integers are each written in base 3. How many of these base 3 representations are palindromes? A palindrome is a number that reads the same forward and backward. First, let's look at 2007. 2007 base 3, this is going to be equal to 2, yeah, that's going to be equal to 2, 2, 0, 2, 1, 0, 0 in base 3. This is something that you have to actually calculate on your own. And so we will say that we have got this, and we will proceed. Okay, so we need all the palindromes that are possible below this value, which is only made up of 0, 1, and 2. So if we have a one-digit number, that's also called a palindrome, right? So we have 1 and 2 because 0 is impossible. And for 2 digits, we have 1, 1 and 2, 2. That's also 2. For our three-digit numbers, we have 1, 0, 1, or yeah, but then these two have to be the same. So this can have 1 or 2, and this middle value can have 0, 1, or 2, right? So this is 6. And the next is the 4-digit 1, 0, 0, 1, and since these two and that two are the same, that means we have 1, 2 choices for here and 0, 1, 2 choices for here. And for our 5 value, that'll be 1, 0, 0, 0, 1. So we can choose of these 3. So this is 2 times 3 times 3. And then for our 1, 0, 0, 0, 0, 1, and that would just have the 3 values. We can choose those 3. So we have 2 times 3 times 3. And then for 1, 0, 0, 0, 0, 0, 1, we can choose 1, 2, 3, 4. If we calculate, this will be 2. This will be 2. This will be 2 times 3, which is 6. This is also 6. And this is 1 times 3. That's 2 times 3 times 3. That is 18. This is also 18. And this is 2 times 3 times 3 times 3, which is 54. But then notice that we can't do some things from this last one. We see that, so from here, the 7-digit one, we see that 2, 2, 1 something, 1, 2, 2, this is all impossible. And same thing, 2, 2, 2 something, 2, 2, 2, they are all impossible, right? So this has 3 choices and this has 3 choices, so we have to subtract 6 choices, right? So we have to subtract 6 choices. If we add everything, 2, 2, 6, 6, 18, 18, 54 minus 6, right? So that would become, this is 10, and these two cancel, and 18 plus 18 is just 36, right? So this is 36 plus 54, so those two get up to 90, so it's 90 plus 10, which is 100, so 100 is our answer. It's A. Number 22, 2 particles move along the edges of equilateral triangle ABC in the direction A to B to C all the way back to A, starting simultaneously and moving at the same speed. One starts at A and the other starts at the midpoint of BC. The midpoint of the line segment joining the 2 particles traces out a path that encloses a region R. What is the ratio of the area of R to the area of triangle ABC? Okay, so if we bring out this equilateral triangle, right? So let's say that the top is A, then this is B, and this is C. And so if one starts at A, then the other would start at the midpoint of BC, right here. So this will be the other particle. The first midpoint would occur right about here. If the particles go half of AB, that means half of BC, so that means that they just also end up at C to the midpoint of A and B, right? So so here we have one more point, and that will be about right here. And the same thing, this goes half, and then this goes half, and that will give us from B to the midpoint of AC, right? So like that. And so our last point, that will be over here, right? Since we know that ABC is a triangle, then it makes perfect sense to say that this is a triangle as well. And it will also be an equilateral triangle, right? and so this will be an equilateral triangle like that. But then see this point where they all meet, that is the centroid of the triangle. We know that the ratio of the area, that's 2 to 1, right? But then since these are all the midpoints, right? Since these are all midpoints, that means this length to that length is just 1 to 1. And so if we just make these all the same, then that would just be the ratio to be 4 to 2 and 3 to 3, right? So that would just make the whole thing 6, and so this is 4 and this is 3, right? And so since we know that this much is 4 and this much is 3, right, then we know how this much is. That is just 4 minus 3, and that's just 1, right? And so we get that this much is equal to 1, right? But then it's 1, the whole thing is 4, right? So 1 from 4. So 1 out of 4. No, that's just 1. And what we wanted is r to the area of ABC, and so this is r, and then this whole thing, that's ABC, and since they are both equilateral triangles, they are similar, right? So so r to ABC length ratio is going to be this length to this length, right? So it's 1, so it's 1 to 4, right? So the ratio is 1 to 4, right? So let's write that again, 1 to 4. And so we want the ratio of the areas. So the area ratio is 1 squared to 4 squared, which is 1 to 16, right? So this is going to be 1 over 16. So this is the answer. It's A. Problem number 23. How many non-congruent right triangles with positive integer like lengths have areas that are numerically equal to 3 times their perimeters? Okay, so if we just bring out a right triangle over here, then that would give us that, let's say this is a right angle and this is A, B, and C. Right, that would just simply give us, since it's a right triangle, A squared plus B squared equals C squared, right? And since the areas are equal to 3 times their perimeters, that means half of AB is equal to 3 times A plus B plus C. So that means AB equals 6A plus B plus C, right? And so using this one, A squared plus B squared is equal to A plus B squared minus 2AB, so this is equal to C squared, and then since A plus B, that is, so from here we get that A plus B equals AB over 6 minus C, right? And so if we substitute that into here, then that will give us, so that will give us AB over 6 minus C squared minus 2AB equals C squared. And this is AB squared over 36, so it's AB squared over 36 minus all over 6, and then ABC, this minus 2AB, and then plus C squared equals C squared, right? So these two will cancel out, and then if we divide 1AB by here, that gives us AB over 36 minus C over 6 equals 2, right? Sorry, minus 2 equals 0, so that equals 2. So if we multiply everything by 36, then that's going to give us AB minus 6C equals 2 times 36, which is 72. So AB equals 6C plus 72, AB equals 6 times C plus 12, right? But then we saw this before. AB equals 6 times C plus something, that's AB equals 6 times A plus B plus C. So since 12 is equal to A plus B, right? So that gives us 12 equals A plus B. A plus B equals 12. They have to be non-congruent. So that means A can be up to 1 to 6, right? So this is 6 values, and so that's why the answer is 6. It's A. Number 24. How many pairs of positive integers A, B are there such that GCD of A, B equals 1? And this is an integer. So first of all, since GCD of A and B equals 1, that means A and B are mutually prime. Right? And so this is going to be 9A squared plus 14B squared over 9AB. This is an integer, right? So that means that for this one, that means B squared will be a multiple of 9, right? And 14B squared is going to be a multiple of A. 14B squared is going to be a multiple of A. And also from this, 9A squared is going to be a multiple of B, b squared will never be a multiple of a, and a squared will never be a multiple of b, right? That means that we can just erase these b squared and 9 and a squared from there. And so we have these three things. B is a multiple of 9. This means that, so this means that b is a multiple of 3. Multiple of 3. That's a b. Yeah. Since 14 is a multiple of a, that means a equals the factors of 14, which is 1, 2, 7, or 14, and there aren't any other restrictions, right? And then since 9 is a multiple of b, that means b is a factor of 9, so b equals 1, 3, or 9, but b can't be 1 because b has to be a multiple of 3, right? So 1's out of the picture, and b is equal to 3 or 9. But then look at if b equals 9, right? If b equals 9, then this whole thing is going to be a over 9 plus 14 times 9 over 9a. So these are going to go away. And since a is 1, 2, 7, 14, this is going to be an integer. But then this is not going to be an integer, right? And so the whole thing is not going to be an integer, so b cannot be 9, right? So b cannot be 9. So b is only equal to 3, right? So b is only equal to 3. And a has 4 values, so this gives us 1 times 4, so 1 value for b, and 4 values for a. This is equal to 4. So the answer is 4, it's a. Number 25, points A, B, C, D, and E are located in a three-dimensional space with AB equals BC equals CD equals DE equals EA equals 2, and ABC equals CDE equals DEA equals 90 degrees. The plane of ABC is parallel to DE. What is the area of BDE? Okay, so since this is a three-dimensional thing, it's going to look something like this picture, right? Understanding, let's go look at like a 3D picture of what this is look like. And so this site is math3d.org, right? And here you can just get a picture of what this thing actually looks like, right? And so this is A, B, C, D, E that we have here. Notice how ABC right there, that's a right angle, and then right here we see that BCD and CDE prime, those are right angles, and here we see that D, E, and A, they are all right angles. And notice how from the top, right, then it becomes a something like a equilateral triangle, right? Because if you see here, DC and BE, they are the same, and so if we drop DC down to BE, then that is going to be an equilateral triangle, right? And so if we just bring that back to our board, this is basically what it looked like, right? And so again, this is 2, this is 2, this is 2, this is 2, this is 2. They are all the same length, right? And then ABC is CDE is DEA equals 90 degrees, right? And so that means ABC, this angle, equals CDE, this angle equals DEA, this angle, which is equals 90 degrees, and this also equals 90 degrees, right? And I talked about dropping DC down to BE, right? And then if we do that, then that will look something like that, right? And we want the area of BDE, right? The area of BDE. So that is going to be a right isosceles triangle, because this length is 2, this length is also 2, and this is a right angle, right? And so if we draw DB like that, then our area, so this area, this is going to be 2 times 2 times 1/2, which is equal to 2, right? So this is our area of BDE. That's the answer, it's C. And so that was the end of the AMC 12B from the year 2007. So thank you for watching.